Solving quadratic equations. The first step is to attempt to factor the quadratic equation, and I need to set it in this standard form. So that's what we're going to do. We're going to rewrite our equation in the standard form. ax squared plus bx plus c equals to 0. That means the very first step is to add 10 to both sides. And that gives us x squared minus 7x plus 10 is equal to 0. Since it is equal to 0, we can attempt to factor this equation. And it has three terms, so I'm going to use the diamond method. 10 on top, negative 7 on the bottom, and the two numbers that multiply to get 10 and add up to get negative 7 is negative 2 and negative 5. This factors as x minus 2 times the quantity x minus 5 is equal to 0. Since these two factors multiply to give us a 0, that means either x minus 2 is equal to 0, or it could be x minus 5 is equal to 0. Let's add 2 to both sides to solve for x. And so x is equal to 2. For the other equation, we will add 5 to both sides. As a result, we have x is also equal to 5. So we have two solutions for this equation. The two answers are 2 and 5. In example 2, again, I want to rewrite it in that standard form. So let's subtract 2x to both sides. That gives us x squared minus 2x is equal to 15. And then we're going to do it again. We're going to subtract 15 to both sides. So this equation is equal to 0. That gives us x squared minus 2x minus 15 is equal to 0. And now we could attempt to factor the equation. This has three terms. Let's put the negative 15 on the top and the negative 2 on the bottom. What two numbers will multiply to get negative 15? That's 3 and 5. But one of these has to be negative. It must be the negative 5. This factors as x plus 3 times the quantity x minus 5 is equal to 0. Since x plus 3 and x minus 5 multiply to give us 0, that means either x plus 3 is 0, or it could be x minus 5 is equal to 0. For the first equation, we'll subtract 3 to both sides to solve for x. That gives us x equals negative 3. For the second equation, we will do something similar. Let's add 5 to both sides. As a result, we have x equals 5. We have two answers to this question, negative 3 and 5. In example 3, we will again try to rewrite it in that nice standard form. So I'll subtract 49 to both sides, and we have x squared minus 49 is equal to 0. Now this doesn't have three terms, it has only two terms, so it's got to be the difference of squares. The formula for that is a squared minus b squared equals a plus b times a minus b. Let's rewrite this as x squared minus 49 can be rewritten as 7 squared. And so it looks like the equation now. We have a squared minus b squared. This x is our a, and this 7 is our b. According to the formula, this factors as x plus 7 times x minus 7 is equal to 0. And that's by substituting a and b into our formula. As a result, we have x plus 7 equals 0, or x minus 7 equals 0. And so we could subtract 7 to both sides for the first equation to solve for x. This gives me x equals negative 7 for the first equation. For the second equation, we'll add 7 to both sides. And this gives us x equals 7. We have two solutions in this case. The first one is -7, and the second one is +7. For the next strategy, it's known as extracting the square roots. We'll have to isolate the square term first. Take the square root of each side, and don't forget to put the plus or minus sign in front of the square root of the constant term. We'll simplify the square root, and then we'll solve by isolating the variable. So let's look at example 4. If you were to attempt to factor this, it would not work because 50 cannot be rewritten as something squared. 50 is not a perfect square, so we cannot factor this problem. So what we're going to do is isolate that x squared term. So let's add 50 to both sides. This gives us x squared equals 50. The next step is to take the square root of both sides, and you cannot forget the plus or minus in front of the constant term. When we're taking the square root, we have to account for the positive and the negative solution. On the left, the square root of x squared is just x. On the right, we have plus or minus the square root of 50. We could simplify the square root of 50 as 5 times 2 times 5. Now we're looking for pairs. I know 50 is 5 times 2 times 5, so I have a pair of 5s. This means I can simplify my solution as plus or minus 5 root 2. There's a 2 left on the inside. And so we do have two solutions, -5 root 2 and +5 root 2. In example 5, we'll start by taking the square root of both sides. Don't forget, you need that plus or minus in front of that constant term. Always put it in front of that constant term here. On the left, it simplifies to x. On the right, we have plus or minus the square root of 28. Which I could break down with my prime factorization skills. This is 2 times 2 times 7. And you could always double check. 2 times 2 times 7 is 28. So that looks good. We're looking for groups of 2. I have one there. So this simplifies as x equals plus or minus 2 root 7. Again, we have two solutions, -2 root 7 and +2 root 7. In example 6, again, I'm going to start by isolating that square term. It's already by itself, so we'll just have to take the square root of both sides. Don't forget that plus or minus in front of that constant term. This gives me x squared equals plus or minus, and we have a square root of a negative. You have to remember, pull out that I to the front, and we have left over the square root of 16. On the left, we can simplify that. The square root here will cancel out, so that's x equals plus or minus. We know the square root of 16 is 4, so we'll put that in the front, and we have to multiply that with I. So we have two solutions. It's plus or minus 4i. In example 7, we'll isolate that squared term, get that by itself. So let's subtract 32 to both sides. We have x squared equals -32. And now we can take the square root of both sides. Don't forget that plus or minus in front of that constant term. And so this simplifies to x equals plus or minus, and there's a negative inside the square root, so I'll always pull out the I first, and then we will do the prime factorization for 32. That's going to be 2, 2, 2 5 times, and we'll look for groups of 2 here. I have 2 pairs of 2's, so this gives me x equals plus or minus. We have a 2 times a 2 for each of these pairs here, and inside we have a 2. So this can be simplified as plus or minus 4, because 2 times 2 gives me 4, for I root 2. And so we do have two solutions, negative 4i root 2 and positive 4i root 2. Let's look at example 8. Now in example 8, a lot of people might be tempted to FOIL this out, but you're going to make your life a lot harder. So don't do that. Do not FOIL this out. It's best to actually start by getting rid of that square term. And how do we do that? We're going to take the square root of both sides. Let's take the square root of both sides. Don't forget that plus or minus in front of that constant term. And on the left, what happens? The square term cancels out. And so we're left with 2x minus 7 equals plus or minus the square root of 25. And that's a lot less work than FOILing it out. This is a lot quicker. And you will realize that the square root of 25, that is 5. Now the next step is to solve for x, so let's add 7 to both sides. Now you want to be careful with that 7. I like to put it in front of the plus or minus. So this is rewritten as 2x equals 7 plus or minus 5. Now don't evaluate the right side yet. Always wait till the end. Instead, divide both sides by 2 so you can isolate that x. X equals 7 plus or minus 5 over 2. Now this is the point where we can evaluate it. We can write one equation where it's 7 minus 5 over 2, or we could write the other equation 7 plus 5 over 2. So we're now separating it. We always wait till the end to do this. 7 minus 5 divided by 2, that's going to give us 2 on top. 2 divided by 2 gives us a 1. So the first solution is x equals 1. For the second solution, you have 7 plus 5, which is 12. 12 divided by 2 gives us 6. So the second solution is 6. So the best advice is not to FOIL out the 2x minus 7. It's better just to start by taking the square root of both sides. It just makes it simpler in the end. In example 9, I want to do the same strategy, so we'll start by subtracting that 35 to both sides. This gives me the following. It gives me 3x plus 4 squared equals 15 minus 35, that's negative 20. Now I can take the square root of both sides. Don't forget that plus or minus. On the left, it simplifies to 3x plus 4 because the square term cancels out with the square root. On the right, I'm going to pull out the I first, and that leaves us the square root of 20. Well, 20 can be broken down as 2 times 2 times 5. And so we have a pair of 2's. This is 3x plus 4 equals plus or minus. Now that 2, I'm going to bring it to the front of the I, so that's 2i root. We have a 5 on the inside. Now we can subtract that 4 to both sides. And again, when I do this, I like to put it in front of the plus or minus. It will be a lot clearer to the reader that it's outside of the radical and it's in front of the plus or minus. So let's rewrite this as 3x equals negative 4 plus or minus 2i root 5. We need to isolate that x, And that means we need to divide both sides by 3. Let's divide both sides by 3. And now we have our solution. X equals -4 plus or minus 2I root 5 all over 3. This is the simplest we can make it. We have to stop here because we can't simplify it any further. In the previous problem, we were able to simplify it further, but in this problem, we can't. We have to stop here. Let's look at example 10, and a lot of students feel that they have to FOIL this out. No, don't do that. It's going to make a lot of work, or they'll try to distribute that 2 throughout. You can't do that. You would have to FOIL first, so don't try any of those methods. The best way is to isolate that square term. So we'll start by subtracting that 17 to both sides. And this gives me 2 times 2x minus 3 squared equals -18. We might be tempted to take the square root of both sides, but we need to isolate this to x minus 3 first, so I'm going to choose to divide both sides by 2. And that will get rid of that 2 in front of those parentheses. This simplifies to 2x minus 3 squared equals -9. And now I could take the square root of both sides. Don't forget that plus or minus in front of the constant term. And now we have 2x minus 3 equals, we have a negative inside the radical, so let's pull out the I to the front, leaving us with the square root of 9. Now I could add 3 to both sides. And so we have 2x equals, we always put it in front of the plus or minus, so this is 3 plus or minus I root 9. But wait, I can simplify the square root of 9. The square root of 9 is just 3. So we have 3 plus or minus 3i here on the right. And now we could solve for x. Let's divide both sides by 2. And that gives us x equals our final answer. So our final answer is x is equal to 3 plus or minus 3i all over 2. We can't simplify the numerator because we cannot add 3 plus 3i, so we have to stop here. Now we're going to learn a third strategy. So the first one was factoring. The second one was extracting the square. Now the last strategy is called completing the square. The first thing you have to do is rewrite your quadratic equation in this form. We want to rewrite it in the form ax squared plus bx equals to c. Then we're going to add to both sides of the equation b divided by 2 squared. This is going to allow us to factor the resulting equation. We're going to use extracting the square, and then we will solve the resulting equation. So let's give this a try for the first example. And to be honest, in the first example, I would always try to factor first, because if I can factor, I can solve the problem in a few minutes. Completing the square is reserved for questions that are not factorable. So in example 1, it is factorable and you would be done really quickly, but we're just practicing completing the square, and sometimes completing the square is more useful or even possible, and factoring is impossible to do. So let's try example 1. I want to rewrite it by adding 16 to both sides. We have x squared minus 6x. I'm going to leave a blank space here equals 16, and then I'm going to leave another blank space. Why do we do that? Well, we need to add b divided by 2 squared to both sides of the equation. And in our problem, our b is -6. We'll take -6 divided by 2 and then squared. So this is the number we need to add to both sides. Negative 6 divided by 2 is negative 3 squared, which is 9. So that's that number that we need. I need to add the 9 to both sides of the equation. So always leave yourself some space so you don't forget that you need to add it to both sides of the equation. On the left, we will be able to factor that. So let's use the diamond method. We have 9 and negative 6. The two numbers are negative 3 and negative 3. And so this factors as x minus 3 times x minus 3 equals, on the right we just get a 25. Now what's another way to rewrite x minus 3 times another x minus 3? I could rewrite that as x minus 3 squared equals 25. Now that's great because what can we do to get rid of that square term? We could take the square root of both sides, and don't forget that plus or minus. So it just makes it easier now. We can get rid of that x minus 3 squared term, and it just becomes an x minus 3. So we have x minus 3 equals the square root of 25. Well, that's just 5. So we have plus or minus 5 on the right. And so I can now solve for x. Let's add 3 to both sides. So x equals 3 plus or minus 5. So we have two solutions. We'll do the 3 minus the 5 first. That gives me a negative 2. And then we'll do 3 plus 5. And so that gives us x equals 8. We have two answers, negative 2 and positive 8. Let's try question 2. Again, for question 2, it might be possible to factor, but we're trying to practice using complete the square because it is a new strategy. So let's try it here. I want to subtract that 20 to both sides. Again, I want it to be rewritten in this form where it's equal to c. And so now we are rewriting it in that form, leaving ourselves some space so we could complete the square. Now the b is the 8. So we'll take b divided by 2 squared, and that's 8 divided by 2 squared, which gives me 4 squared, or 16. So that's our number that we need. 16 here, 16 here. And so this on the left can be factored as x. Let's see with the diamond method what that is. We have a 4 and 4. So this factors as x plus 4 times x plus 4 equals, on the right, this is negative 4. Now, what's x plus 4 times x plus 4? I could rewrite that as x plus 4 squared equals negative 4. Now, what do we do next? We can take the square root of both sides. Don't forget that plus or minus in front of that square root. And so that leaves us with x plus 4 on the left equals plus or minus. Well, we have that negative in the radical, so let's pull out the I, leaving me with the square root of 4. We can simplify the right. The square root of 4 is 2, so this is plus or minus 2i. And now we could solve for x. Let's subtract the 4 to both sides. And so we get x is equal to, again, I want to put in front of the plus or minus. This is negative 4 plus or minus 2i. So we get two solutions again, negative 4 minus 2i and negative 4 plus 2i. Now you will see a pattern. If you look at the previous question, we have a 3 and a negative 3. And if you look at this question, we have a 4 and a 4. So will this always be the same number? Yes, if you complete the square properly, these two will always be the same number. And a good trick is to look at the b. If you take the b and divide it by 2, you get -3. So that's the quick strategy to factoring this. You take the b, divide it by 2, and it ends up being this and this number. So let's look at the second example. I take the 8 and divide it by 2, and we get 4 and 4. So that's the number that we put in here when we're factoring it. It's always b divided by 2 goes inside of those parentheses. So we're going to use that trick in the next question. Now this is going to be more difficult than the previous problem because the middle term is odd. And since it's odd, it's not going to be divisible by 2. So we'll start by adding the 10 to both sides, or actually 18 to both sides. And this gives me x squared plus 7x. We'll leave ourselves some space, equals 18. Again, leave yourself some space for both sides. Now, I'll take the b, which is 7. We'll divide that by 2. 7 divided by 2 squared is 49/4. And that's ugly. And the reason we use 49/4 is because we have an odd number. It's going to be impossible to divide by 2, so it's going to give us a fraction. Now on the left, we have to factor that. We have to factor the left side. And I told you the trick. The trick is to take the b and divide it by 2. So this factors as x plus 7/2 times another x plus 7/2. And if you're not sure, you can actually FOIL this out and it works. So when completing the square, that middle term divided by 2, it goes right here. So that's a good trick to remember. Now on the right, I have to get common denominators to make this work. So let's multiply the 18 on the top and on the bottom by 4 just to get common denominators. On the left, we can rewrite this as x plus 7/2 squared. Now on the right, I can multiply 18 times 4. 18 times 4, that's 72. 72 divided by 4 plus, right here, plus 49/4. Now we could add these two together because they have the same denominator. So we'll rewrite this as 72 plus 49/4, and we can simplify the top. 72 plus 49, that gives me a 121. So this is 121 on the top and a 4 on the bottom. We can now take the square root of both sides. Don't forget that plus or minus. And so this simplifies on the left as x plus 7/2. On the right, we have the square root of 21 divided by the square root of 4. And this is using the quotient rule for radicals. And so this gives me x plus 7/2 equals plus or minus, we have the square root of 121 is 11, and the square root of 4, that's 2. We're almost there. We got to solve for x. So let's subtract 7/2 to both sides. And let's rewrite this as x equals -7/2 plus or minus 11/2. Since they do have the same denominator, we can rewrite this as -7 plus or minus 11 all over 2. Don't stop here because we can simplify the numerator. We can rewrite this as -7 minus 11/2, or I could write it as -7 plus 11/2. And this gives us two answers. The first answer is -9. And the second answer, if you were to do -7 plus 11, then divided by 2, you get x equals 2. So So this problem was a little bit more difficult than the previous question because of that odd middle term. We couldn't divide it by 2.